Chapter 10 Circles. Now let us move on to a very important theorem. The perpendicular from the center of a circle to the chord bisects the chord. Perpendicular from center of a circle to chord bisects the chord. So first of all, what do I need? I need a circle. So let me consider a circle first. Suppose this is the circle. Perpendicular drawn from center of the circle to the chord. I need to draw a perpendicular from the center of a circle to a chord. For that, I need a chord. We already know chord is a line segment joining any 2 points on the circle. So suppose this is the chord. Now, we are supposed to draw a perpendicular from the center of a circle to the chord. So let this point over here be say center of the circle, and from the center of the circle we are supposed to draw a perpendicular to the chord. So quite obviously the perpendicular has to be like this. Now the statement says that this perpendicular drawn from the center to the chord bisects the chord. That is, it divides the chord into two equal parts. So let us see now. We have given in a circle with center O, OM is perpendicular to chord AB. So let us name the chord and center of the circle now. Point O is the center of the circle and AB is the chord. So O is the center of the circle and AB is the chord, and OM from O to M. There is a perpendicular drawn, that is this angle over here is 90 degree. So perpendicular drawn from the center to the chord. Now we are supposed to prove that AM is equal to MB. That is, it bisects the chord. So we are supposed to prove that this part AM is equal to this part MB. So for that we need a construction, and that construction is we are supposed to join OA and OB. So let me join OA and let me join OB. So if I join OA, it would be like this. If I join OB, it has to be like this. So we have joined OA and OB. What happens after joining OA and OB? When we join OA and OB, we get two triangles over here. Which are the two triangles? Triangle OMA and triangle OMB. Now let us try to prove the two triangles congruent. So in proof, we will begin with the two triangles in triangle OMA and triangle OMB. So OM is the left triangle over here, OMB is located at the right. In these two triangles, first of all, we can say that OA is equal to OB. OA and OB are equal because they are radii of same circle. So we can say this OA and this OB. Both are equal because they are radii of same circle. After that, we can say OM is equal to OM. Now OM is in the middle. Obviously OM will be equal to itself, as OM appears in both the triangles. It is called as the common side. And the third part, we can say that angle OMA over here is 90. Also angle OMB over here is 90. Therefore OMA and OMB both are equal because they are each 90 degree. Now observe the test properly. We have two sides of the triangle congruent and one angle congruent. But we know there is no SSA test. SSA does not exist. If we are getting side angle, and suppose this angle is 90 degree, that is in a right angle triangle. If the hypotenuse and one side is equal, then we say that the two triangles are congruent by RHS test. So since angle A is 90 degree over here, we will say that these two triangles, that is triangle OMA and triangle OMB, are congruent by RHS test. What is this RHS? RHS means right hypotenuse side. Right angle, hypotenuse and side test. Therefore now we can say that the remaining parts are equal, that is AM is equal to MB, CSCT. You can clearly see here AM will be equal to MB now, because corresponding parts of congruent triangles. So perpendicular drawn from the center of the circle to the chord will always bisect the chord. Suppose this is the circle and we have a perpendicular drawn from the center. Suppose O is the center of the circle and we have a chord like this. Suppose this is the perpendicular drawn from the center of the circle, say OA is the perpendicular drawn from the center of the circle to chord CD, and if it is 90 degree, and if the question is the length of CD is say 8 centimeter, then find out the length of CA and AD. It is very simple. Perpendicular drawn from the center of the circle to the chord bisects the chord. So these two parts will be equal, that is CA and AD will be equal. The entire CD is 8, therefore CA will be half of CD. So CA has to be 4 and AD will also become 4. So in this way there will be some questions to be solved on this theorem. Let us see converse of the previous theorem. So the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Again, first of all, I need a circle. So let me consider a circle now. Now in this circle, first of all, let me mark the center of the circle. So say point O is the center of the circle. So we have point O as the center now. After that, a line drawn through the center of the circle to bisect a chord. Again, I need a chord. Suppose this is the chord now. Again, let me name the chord. This chord is say chord PQ. So there is a line drawn from the center to bisect the chord. So from the center I need to bisect the chord, that is I need to divide the chord into two equal parts. So let me draw a line like this. You can call this as line or line segment. So suppose segment OM bisects chord PQ, that is segment OM divides chord PQ into two equal parts, that is PM is equal to MQ. Now we are supposed to prove that this OM over here has to be perpendicular to the chord, that is angle OMQ or angle OMP has to be 90 degree. So let us see what is given now. Again we can say in a circle with center O, chord PQ of a circle with M as the midpoint, and we are supposed to prove that OM is perpendicular to PQ. The angle formed in the position of this question mark has to be 90 degree. So for that again there is a construction, join OP and OQ so that two triangles will be formed. So let me join OP and OQ. Now after joining OP and OQ, clearly again we have two triangles over here. Again to begin the proof with, we'll consider the two triangles, triangle OMP and triangle OMQ, or triangle OPM and triangle OQM. So let me try to prove the two triangles congruent. Now first of all I can say in triangle OPM and triangle OQM, I have OP is equal to OQ because both are radii of same circle. Then after that already I have this PM equal to MQ. So PM is already equal to MQ. This is because M is the midpoint of PQ, it was given. And clearly I can see there is a common side OM for both the triangles. So I can say OM is equal to OM. Therefore we can say that the two triangles are now congruent by SSH test. You can see here OP is equal to OQ, radii of same circle. PM is equal to MQ because M is the midpoint. And we have OM is equal to OM because it is the common side. Two triangles are congruent by SSH test now. But we are supposed to prove that the angle formed at OMP is 90 degree. I am considering the corresponding parts of congruent triangles as angle OMP equal to angle OMQ. Both the angles will be equal now because both the triangles are congruent. The reason being CPCT, corresponding parts of congruent triangles. But clearly we can say that this PQ is a line segment over here, straight. So the total of angle OMP and OMQ will be obviously equal to 180 degree. So OMP plus OMQ is equal to 180 degree because they are angles in linear pair. We have already studied what are angles in linear pair. If we are having a straight line over here and if we have a ray in between, then sum of these two angles is 180 degree. It is a similar manner. We are having PQ at the base and we are having OM like this. The total of both the angles will be 180 degree. But now if you observe properly, OMP and OMQ both are equal. So from equation 1 and 2, what do we get? We get 2 OMP is equal to 180 degree. Now how do we get this? We have OMP plus OMQ is equal to 180. But OMP is already equal to OMQ. So follow this step now. So I have angle OMP plus angle OMQ is equal to 180 degree. But in the previous step, that is in step number 1, I already have OMP is equal to OMQ. I'm writing down OMP as it is. And instead of OMQ, again I'm writing down OMP because both are equal. So I'm replacing this OMQ by OMP. Again equal to 180 degree. Now what is OMP plus OMP? We can say we have 2 times angle OMP. So this is how we got this step. 2 times angle OMP is equal to 180 degree. So further 2 will be divided and we get angle OMP is equal to 90 degree. So clearly the angle formed over here has to be 90 degree. So we can now say that if a line is drawn through the center of the circle bisecting the chord, then it is perpendicular to the chord. That is, this angle becomes 90 degree over here. So converse of the previous theorem.